So here's a demo of how our application works. So you'll see on the top left corner, I have a Ubuntu VM virtual machine. So virtual machine environment running on the top left. And over here, I have executable in my project folder. If you go into server, then source, and then build, you'll see that there's an executable socket_server. And I will then open in terminal this folder and run that executable. So over here, it's right here. I'll do /socket server. And now it's running the server on port 5006. Now, if you get out of the VM and if you open the project again on Visual Studio Code, or you could use any terminal. I'm using Visual Studio's terminal. You'll see that there is a small proxy.py script. This script allows the communication between the server and the client. Since we're using React isn't able to communicate with raw TCP. So that's why we need to take that raw TCP coming from the server and translate it to WebSockets, which React can work with. And so in order to run that script, I just do py and then the name. In this case, it's called small proxy. So now that server, our proxy server, is running on 8080. Now I'll start the client by doing a npm start. And you'll see that a browser will open with the UI, which it did. And what I'll do, I'll make another instance of this so that we can have two clients. So our first client, let's call them Elvin. And I'm going to join chat. And our second client, let's call them Ben. And let's join chat. Now, our first client's going to join room 1. So I had a previous chat I was testing with, so it actually does save previous chats, but for now we'll ignore it. I will demonstrate this though. So what I can do quickly to demonstrate that past chats are being held is if Elvin here says, "Is anyone here?" question mark. And I'll send a chat. You'll see that okay, so he's not in a room, so that's why I didn't show yet, but they'll say, "Is anyone here?" So let's make another client. What's it called? Start. No, localhost. Let's call this Xavier. Join chat. If he joins room 1, you'll see that previous chats are stored and "Is anyone here" does appear. So it even says when it happened, it was 9:40 p.m. And right now it's 9:41 p.m. So that is accurate. Their message was at 9:40 p.m. And now I can actually communicate with Elvin here. So I'll write, "How are you? I am here." And you'll see it actually appears on Elvin's screen. "How are you? I am here." And so now I can say back, "Oh, that's so cool." I don't know. That's so cool. And there you go. And you'll see that it appears on Xavier's screen as well. Now, going back to the other person I made, Ben, if I try to join room 1, it doesn't let me because there's 2 people already in it. It is full. So instead, I'll join room 2. And again, I was testing from before, so that's there, but you would obviously you don't see this chat. This is my test from before. Now I'm going to be demonstrating that chats are stored even when the server isn't running. So right now you'll see I did a Control-C, so the server isn't running. I did a Control-C for the proxy and the Control-C for the client side. So it terminated all of them. Now if I run it again, the server's running again. And then if I do the same thing for the the proxy server, and if I do an npm start, and let's name ourselves Elvin again, join chat. Now, what's interesting is if I actually make another client and call myself Elvin, it will actually say that username is already taken because I just did Elvin with the other one. So it won't allow me to have 2 of the same usernames. And this is used for the server so it can differentiate which user is what. So the usernames kind of work as a unique ID. So I'm just going to do Ben joined. And so now you'll see if I go back to room 1, which we had our previous talk with Xavier, you'll see that everything shows up, the past history. And if I go as Ben, even though Ben wasn't in that chat, he'll also see the previous chats, both from X and A, Xavier and Alvin. So this is how it kind of looks side by side. For Alvin, since he communicated, so this is why his text is on the right side. But since Ben wasn't in this conversation, he only sees X and A. He doesn't see any conversations coming from him. So if I actually write something like, "Hi, I'm Ben," you'll see it shows up for Alvin as a different letter as well.
All right. So in terms of the improvements we made to the server, we implemented scheduling and deadlock handling. So in terms of the type of scheduling that we implemented was we implemented a simple thread pool. So for the thread pool, right now the size of our thread pool is just 20, which corresponds to the max size of our application so far. With 10 rooms and 2 users per room, we should really only have a max of 20 people. So therefore 20 threads. So what's going to happen is on startup, we initialize 20 threads and put them immediately to sleep. And then every single time on connection, it's going to be that socket, that client is going to be pushed to this client queue. Yeah, to this client queue, which right after is going to notify, it's going to basically notify a thread. It's going to wake up a thread that's available, if there is one that's available and sleeping, and that thread is going to take control of that socket of that client and now be in charge of all the connection and all the interactions to do with that individual socket / client. This client queue is going to be used on a first come first serve basis. So if all the worker threads are being used, then the client queue will just continue to accumulate, and then as a client disconnects, then the next client in queue will be taken over by the next available thread. Now, in terms of deadlock handling, before we just implemented basic mutexes, and we just manually locked and unlocked them. Now that can cause a lot of issues. So for our basic deadlock handling, a couple of things we decided to do. So rather than having just one mutex that's used for every single variable, that's used in every single case, we decided to implement a couple individual mutexes for different resources that are being used. So the queue mutex is just used for the thread pools, so that's kind of isolated. But for the client mutex and the room mutex, these are what's going to be used by the individual individual connections. So the client mutex is really going to handle anything to do with the actual client. So tracking its name, having to do anything with reading its socket or getting its name from its socket. And the room mutex is really for checking the actual map we're using to keep track of who's in what room, and then the occupancy of each room. So we also, the way we lock these now, we did change it. So rather than just manually locking and unlocking, we now use lock guards as well as a scoped lock. So what all these will do is, one of the biggest things that will happen is all of these will automatically unlock once it leaves the scope. Once it leaves its scope, that's defined. So anytime that, for example, there's an exception, some error happens, a client leaves, the actual lock will automatically unlock itself after it leaves that scope. So there is no chance for it to leave and then the lock will be locked forever. So that's good. We also used the scope locks. Now what's nice with these is whenever these are used in any context, the scope locked is always going to lock, because it's multiple locks. It's always going to make sure it locks each mutex in the same order globally. So there will be no instance where if we're locking, if we're using two different mutexes and we're locking both of them, then for example, if thread one wanted to lock room mutex and then client mutex in that order, and then the thread two would want to do like the client mutex and then the room mutex, that would never happen. Yeah, that case would never happen because we're using the scope lock. It would always choose one orientation, and that is all handled like in the background. Also, to improve our exiting of the program, we also had this atomic variable that each thread is going to check. So it just checks for the server running flag, and then if this ever turns false, then the threads will all gracefully shut down to prevent any further deadlocks and to end the program gracefully.